Okay, we're in section 19 doing the homework. And again, the intent here is that, not for me to do your homework for you, but some people need to watch someone do the homework first before they can attempt it. And again, at some point, you want to become more independent where you're doing the homework on your own. Now, some of the advantages of the key that we're giving you over here is that you can look at the key as you're doing the problems. But again, what I would suggest to do is on a separate sheet of paper, work the problems, then look at the key. All right. Because sometimes you're going to be misled by looking at a key thinking, yeah, I can do that, when in fact you haven't done anything. All right, so let me switch screens now. And give me 1 second to do so. Okay. So what am I going to do over here? I'm going to look at the problem. I'm going to pull it to the side. Let me push this over a little bit. And let me start writing it down. So what do I see? I see number one. They want me to find the derivative of y equals 4x times the natural log of x minus 3x. Let's write this down. So it's going to be y prime, also dy dx. I have to use the product rule. So I'm going to say the first function, 4x, times the derivative of natural log of x, which is 1 over x, plus the derivative of the first function. Well, the derivative of 4x is 4, times the second function, which is the natural log of x, minus the derivative of 3x is going to be 3. Let's write this down. And again, x is greater than 0. So this simplifies to 4 plus 4 ln x minus 3. And 4 minus 3 is 1. So it's 1 plus 4 natural log of x. All right, I want to look at the key. And I want to emphasize the key is given to you for a reason for you to look at it. So I have this and I have this. That's correct. Let's go to number 2. And number 2 is, I'll write this down for you, is y equals the natural log of 3x raised to the 5th power. Chain rule, so dy dx, same thing as saying y prime in this case, as long as you know y prime means dy dx. What's going to be 5 natural log 3x to the 4th power times, well, the derivative of the inside is 1 over 3x, and the derivative of the inside of the natural log of 3x would be the derivative of 3x, which would be 3. I want to simplify it, and what do you get? You get 5 over x times the natural log of 3x raised to the 4th power. Let's look at the k. And again, the reason for looking at the key is to make sure whatever you're writing down, you can agree with it. So I'm looking at this over there, looking at that over there, and I'm in agreement. All right, let's go to number 3. And this one has a different variable in it. It's a t. So let's write this down. So what do you have? You have y equals, and that's the natural log of t times a to the t. Now, what I would recommend over here is simplifying the log first. Someone says, well, I don't want to do that. We're not saying you have to do that. We're just saying it might be easier to do that. And what I mean by that is this is a sum now. So it's natural log of t plus the natural log of a to the t. All right, I'm going to claim that's easier for me to deal with. And certainly when someone says, why is that? Well, I got rid of a product. Now I have a sum. But I still have that exponent. So I'm going to use, the rules I learned in Math 119. This is natural log of t plus t times the natural log of 8. Now I can take my derivative. So y prime, and you should understand that y prime is dy dt. Well, the derivative of the first term is 1 over t. That was simple. And the derivative of the second term, also very simple. What do you get? Just the natural log of 8. Again, I'm going to recommend to look at the answer k, and I'm seeing it. All right, let's go to the next one, number 4. And number 4, I want to, again, claim to you that, if you can, simplify the log first. So number 4, whoops, get back to white ink, is, I'll go through this. It's y equals the natural log. I'm going to write this as a power. Well, first thing I'm going to do is bring the power down. You kind of using the rules I learned about Math 119. I'm going to keep moving forward. And again, this is not the derivative. This is just me simplifying it. We get 1/2 ln, and that's a quotient. So the quotient can be rewritten as a difference. All right, what am I going to do now? dy dx, the same thing as y prime in this case. And what do you get? 1/2 1 over x squared minus 1 times 2x, we'll simplify it later, minus 1/2 x squared plus 1 times 2x. All right. Now, so I realize some students want to put a box in that. I'm not opposed to it, but I'll be honest with you, it's really just poor form. So what I want to do is I'm going to add these two together. And as I do that, I want to simplify them. And what do you get? You get x over x squared minus 1 minus x over x squared plus 1. Well, again, some people would box that and say that's as far as I want to go. Well, let me keep going. I want to go to the end. And I think there's something else I could do. Common denominator. Again, for the students who go faster, go faster. If it's taking you time to work through this, take your time to work through it. Your goal is to get it, though. It's not to just say, oh, it's not worth it. It is worth it. Let me keep moving forward. The bottom actually multiplies out pretty nicely, so I'll do that. That's x4 minus 1. And what do you get on top? Well, you get x cubed plus x minus x cubed plus x. And this simplifies really nicely. What does it give you? 2x over x4 minus 1. I think that's the best looking answer. It's also the easiest one to analyze. And at some point, we have to use a derivative to analyze them. And certainly, I want to go back to the k, and I want to see if that's in the k. So in other words, I'm wondering, is this answer in the k? And if not, I got some struggle with it. And I'm seeing it. I'm seeing the answer. And again, you definitely want to look at the key, because the key is going to allow you to self-validate that you're doing things okay. If you ever think there's a problem with the key, though, you should bring it to my attention, and I'll certainly look at it. I'm not going to say I'm always right. Let's go to number 5. Number 5, I want to be honest with you, for a lot of students, is problematic. They write a wrong answer down, but they do it quickly. So this is number 5. And what's 5? Y equals 12 to the x. So a lot of students write a wrong answer down. And certainly, if you do it quickly, it's not much cost to it, but you're not going to gain anything from it either. You're going to lose things from it. And certainly, it's going to impact your grade. So what I like to do is just go through what I would do to do this problem. I would take the natural log of both sides. And what do you get of your natural log of the left side, have to be the right side, and I'll write this over here. I'd use the rule of logs, and that would be x times ln 12. Now I differentiate. Well, the derivative of the left side is 1 over y dy dx equals, the right side is pretty simple. It's just ln 12. And what do you have there? Dy dx is equal to y times ln 12. And the question is, what's y? It's 12 to the x. So dy dx is 12 to the x times ln 12. What do I recommend you do? Look at this and look at the k. And if they're not the same thing, I got to be honest with you, you're going to have to work towards getting the same thing. All right. Again, let me repeat this. If you believe there's an error, though, bring it to my attention. All right, let's go to number 6. Number 6 is a little bit more difficult. And they want me to get the derivative, certainly, in the tangent line. So let's go through that. And the function f of x is going to be 3 to the x. And they want the equation of the tangent line at the point where x is 4. So when x is 4, f would be equal to, which is the same thing as saying y, well, 3 to the 4. And 3 to the 4 is 3 times 3 times 3 times 3 is 81. So another equation of the tangent line is going to be y minus 81 m tan, I don't know that yet, times x minus 4. Well, let's go for m tan. What's m tan? M tan is going to be f prime evaluated at 4. Well, I need to find f prime. What's f prime? it's dy dx. Well, I just did this, so I think I could probably do this again. Its derivative is going to be 3x times ln 3. What's f prime of 4? It's going to be 81, because 3 to the 4 is 81, times the natural log of 3. All right, so I'm going to write my answer down now. And my answer is going to be what? Y minus 81 equals m tan, which is 81 ln 3, times x minus 4. Box in this. I'm going to check it against the key. Now, some of the key looks different, not substantially so. It's still 81 ln 3 for the slope, x minus 4. The only thing they did was add 81 to both sides. Why would they do that? In Webison, they generally solve the equations for y. Pretty easy to do that. Just add 81 to both sides. Well, let's do number 7. And number 7, a little more complicated. And the root that, it's a log base 6. So before you do anything, what I would recommend you do is rewrite the problem in a log base, either 10 or log base e. I would go base e because the reason for that is base e is easy to differentiate. So what do I get? I get y equals, this is the base change formula that you learned in Math 119. So it's going to be natural log of x, I'm sorry, I made a mistake there. I have to read. 2x squared plus 4 over the natural log of 6. All right. Then what I'm going to do, I'm going to differentiate. I'll go back to reading the question later. What's dy dx? Well, it's 1 over the natural log of 6. That's the constant multiple. The derivative of the natural log is going to be 1 over 2x squared plus 4 times the derivative of the inside, which is 4x. Let's go back and read the question. And they want to know the equation of the tangent line at 4. All right, let's keep going through this. All right. So they want to know the equation of the tangent line where x equals 4. Well, I'd like to know what the slope is at 4. All right, so that's going to be the slope. It's going to be m tan at x equals 4. I need that. And what do you get over there? Well, 1 over the natural log of 6 times, oh boy, I guess I got to do some arithmetic here, right? So 4 times 4 is 16. That's a top number. The bottom number is going to be what? Well, if I thought about that, that's going to be what? 2 times 16 is 32. 32 plus 4 is 36. I guess I could do that further, right? What would that give me? I guess I could divide by 4, right? So I get 4. And 4 goes into 36 9 times ln 6. All right. I still have to find the point. Right. I still need to find the point. So I'm going to go through this over here. So x is equal to, what's x equal to? X is equal to 4, right? So what's f equal to? Well, it's going to be y, or f of x, is going to be equal to log base 6. And you're going to get, well, I just did that, didn't I? And what do you get over there? You get 36. I think I did that before, right? So what's that going to be? Well, let's see, 6 raised to the power 2. So what's the point going to be? 4, 2. Again, we'll check the key. Mistakes can happen. So what do you get over here? Y minus 2 equals the slope, which is 4 over 9 ln 6 times x minus 4. Again, you can simplify that if you want. I'm going to look at the key and see how we did. Let's look at it. I'm looking at this. I'm looking at this. And let's see, did I get the slope right? 4 over 9 ln 6. Yep. X minus 4. The only difference is they added 2 to both sides. All right. Relatively simple question. Go to the next one. And we're on number 8 now. And number 8 says, use logarithmic differentiation. Well, this is something we discussed in class. Let me write this over here. So y, let's get to it, the white ink. So y is equal to 8 times x squared times 6x plus 1 times x minus 9 to the half power. What I'm going to do is take the log of both sides and use those rules that I learned about in Math 119. So it's going to be natural log of 8 plus 2 times the natural log of x plus natural log of 6x plus 1 plus 1/2 natural log x minus 9. All right. Now someone says this looks like a nightmare to me. It looks like you took a problem that was simple and you wrote down something that's much more difficult. Well, maybe so, but the bottom line is this is far easier to differentiate now. So the derivative of the left side is going to be 1 over y dy dx equals the derivative of natural log of a, its constant, is going to be 0. The derivative of 2 times natural log is going to be 2 over x. That was simple. Plus the derivative of the next function is going to be 1 over 6x plus 1 times derivative of 6x, which is 6. The next guy's derivative is going to be 1/2 times 1 over x minus 9. And the derivative of x minus 9 is going to be 1. So I'm not going to write that down. Now I'm going to write down dy dx is equal to y times 2 over x plus 6 over 6x plus 1 plus 1 over 2 times x minus 9. Do I know what y is? I sure do. I'll write that down now. What's y? 8x squared, 6x plus 1. This is y, by the way. The root of x minus 9 times, let's write this down, 2x, 2 over x, plus 6 over 6x plus 1, plus 1. Whoops, I'm running out of room. And that's going to be 2 times x minus 9. That's my answer. And I want to, check it. And what do you check it? Against the key. And I'm looking at it. And again, I hope you're looking at the key as well. And let's see if I got it right. Looking good. Got it right. All right, let's do number 9. And again, for a lot of students doing number 9, they write a wrong answer down quickly. And that's not good, right? The fact that you're quick. But let's write this down now. So y is equal to x to the 8x. I would recommend logarithmic differentiation. So it's going to be natural log of y. And that's going to be 8x times the natural log of x. Again, some students are going to argue this is making it really tough for me. If you do that, well, it's the only way I can take its derivative now. I couldn't take the derivative before. What do you get now? 1 over y dy dx equals, I need the product rule. And what's that going to be? Well, 8 times the natural log of x plus 8x times the derivative of natural log, which is 1 over x. So what do you get over here? Dy dx is equal to y times, let's be careful, this is going to be 8 natural log of x plus 8. What's y? Well, it's x, 8 to the x, and this can be 8 ln x plus 8. I'll put a box in that. Good answer. I do want to simplify a little tiny bit. And I can write down 8 ln x plus 1 times x to the 8x. That's a simpler answer, by the way. Let's look at the k, and I'm looking at this, and I'm looking at this, and it's the same. This is good news. All right, number 12, last question. It says use the formula to show that the derivatives of natural log of x and natural log of 2x are the same thing. I will use the formula, but let me just write this down. I think it's pretty easy to show this. So I'm going to write down y equals natural log of x, and I'm going to write down y equals natural log of 2x. Now they're claiming these are the same derivative. Let's write that down. What's dy dx? It's going to be 1 over x. What's dy dx over here? It's 1 over 2x times 2, which is still 1 over x. Are they the same? Of course they are. But what did they say? They said use the formula. So let's write this down, and we'll go through the formula. And what are they saying? The natural log. Whoops, I'm sorry about that. I'm going to write exactly where they have it over here. Of f of x derivative. What's that going to be? 1 over, and again, this is the argument, 1 over f of x times the derivative of the inside, which is f prime of x. So let's use that, see if we can do it. And let's write this over here. So natural log, the argument's x, its derivative. What's it going to be? 1 over the function, which is x, times the derivative of x, which is 1, which is 1 over x. Next up is natural log of 2x. We're using the formula now. What's that going to be? 1 over twice the argument, which is using the formula, times derivative of the argument, which is derivative of 2x, which is going to be 2. You still get 1 over x. All right, so we verified what they said. What they go on to say is, you have an alternate explanation for this, and let's go for that. So, ln of x equals the natural log of x. And the natural log of 2x is really the natural log of x plus the natural log of 2. So what do I know about these things? These two functions differ by a constant. They differ by a constant. What's the constant they differ by? The natural log of 2. Well, the derivative of all constants are going to be 0, so that makes sense to me. All right, so their derivatives should be the same because they just differ by a constant. If they differ by a constant, their derivatives will be identical. All right, let's look at the key. And in the key where they go, they talk about, this over here. I got that over there. And they get said differ by a constant, which implies the two functions have the same derivative. Thank you for paying attention. Again, I want to remind you, if you have any questions or concerns, please bring it to my attention during office hours, and I'll be more than happy to discuss those with you.